Hi guys, in this video we're gonna briefly talk about the effect of altitude on the maximum straight and level speed. So the maximum straight and level speed is the maximum speed which you can achieve during cruise conditions. And again, after the previous material, we're gonna presume again that during the cruise condition, the main forces acting on the aircraft are going to be the lift, drag, weight, and thrust, and distributed in such a way that the lift is opposing the weight and the thrust is opposing the drag. And so therefore the final equations which we're going to use, and everything of course acting through the center of pressure, the center of gravity. So we're going to have the lift opposing the weight and the thrust opposing the drag. And we're going to go back to this convention because for this discussion this is going to be sufficient. So let's start examining for both the propeller and for both the thrust or the jet-driven aircraft where the maximum straight and level speed occurs. So generally speaking, maximum straight and level speed occurs where the thrust is equal to the drag. Okay, so let's examine the thrust and the drag curve of the jet aircraft, if we still remember it. So let's plot it. Here we have the thrust curve and the drag also. And here we're gonna have the calibrated airspeed. The calibrated airspeed, and we're going to have a given amount of thrust. So thrust curve, let's say low altitude. And we're going to have a drag curve. Okay. So, and of course here you have, here you have the stall speed. Okay, so which is the point where the thrust equals drag equation is true? You can see that the only point where that happens is the intersection of the two curves, and at this given velocity, so VmaxS&L low altitude. So if you have, for example, a higher speed than that, you're gonna get an excess drag, right? Because the drag curve is gonna be higher than the thrust curve. And if you use a lower speed than this VmaxS&L, in that case, you're going to get an excess thrust. Right? For a given amount of thrust setting, this intersection curve is going to be the point where the two coincide and where you will have the maximum amount of velocity for the given cruising condition. Okay, so what happens when pressure altitude increases? And now we're talking about calibrated airspeed curves. So does the drag curve change? No, right? Because in calibrated airspeed, the drag curve remains exactly the same, right? So no change. Does the thrust curve change? Yes, it does, right? Because if you remember, like with the increasing pressure altitude, what we had is a decreasing density. So therefore, the thrust generated by the engine is going to reduce, right? So, let's use this color. So it's going to go lower. The entire curve is going to get shifted lower. So this would be the thrust at higher or high altitude. Okay. So now we're looking at the intersection of the thrust high altitude has to equal the drag, right? So at high altitude, this has to be the equation. Okay, so where that happens is, again, the intersection of the two curves, which is right here, because if you use a higher speed, you're going to have an excess drag, and if you use a lower speed, you're going to have an excess thrust. So what we can see is that this one is going to be the Vmax S&L, S&L meaning straight and level, at high altitude, and the speed got reduced. It's lower now, right? So the effect, and this is like the general effect of the effect of pressure altitude on the maximum straight and level speed. So again, if pressure altitude increases for the jet, if pressure altitude increases, then the Vmax straight and level calibrated airspeed is gonna reduce. So you will need to maintain a lower calibrated airspeed, or you will be able to maintain the thrust, the reduced thrust, at a lower calibrated airspeed than before. And this is the effect for the jet. Okay, now let's examine the same exact thing for the propeller driven aircraft. So for the propeller driven aircraft, we're looking at the same exact equation. So you have I don't know, like a -8. You have a -8. Here you have the propeller. Nice long fuselage, small tail, and center of gravity, longitudinal axis, vertical axis, and we have the same kind of set of forces acting, right? So we have the lift, we have the weight, we have the thrust, and we have the drag, and from this we know that the lift covers the weight and the thrust covers the drag. Okay, so for the propeller driven one, so we need to examine again the thrust equals drag equation, where that occurs, and that's going to indicate our maximum straight and level speed. And we're also going to look at the effect of altitude on that maximum straight and level speed. So let's plot the thrust and the drag curves of the propeller-driven aircraft, just like we did with the jet. So again, let's talk calibrated airspeed. So the thrust curve is a good old one, which we have come to know and love. And of course, the maximum point occurs. I don't let my drawing fool you. Actually, let's correct it. So the maximum point, of course, occurs at the at 0 calibrated airspeed. So that's your maximum thrust which you can generate, and your thrust curve looks something like this. So this is your thrust. Let's say low altitude. And you're going to have your drag curve, which looks exactly the same as it did for the jet airplane. And of course, here we have the stall speed, below which we don't talk about the drawing. Okay, so what we can see is that where the thrust equals drag equation is true, so for this case it would be drag equals the thrust at low altitude is the intersection again of the two curves, and this would be your Vmax S&L at low alt, and this is in calibrated airspeed wise, right? So this is the speed where you would generally speaking achieve the cruise conditions. And what you can see interestingly is that of course at lower speeds you can generate a much higher excess thrust with the propeller driven aircraft, but about that we have also talked. This is why it's beneficiary to fly with propeller-driven aircrafts at lower speed. Okay, so what happens if you climb to a higher altitude is this curve shifts lower in such a way, and what we can see is that the Vmax straight and level for the high altitude occurred at a much lower calibrated airspeed than for the lower altitude, right? So here we have, so the thrust high altitude, so this whole thing shifted downwards, and now we're looking at the equation of thrust at high altitude has to be equal with the drag, right? It has to be equal to the drag to get the cruise conditions. So this would occur at a lower calibrated airspeed. So therefore, we got a similar result as we did in case for the jet aircraft. So what we can say for the propeller as well is that if the pressure altitude increases, in that case the Vmax straight and level calibrated airspeed is going to decrease. Okay. And so yet again, we have the same exact effect for the jet. So in both cases, we can see that for both the jet and for the propeller-driven aircraft, if you have an increase in the pressure altitude, your maximum straight and level speed in calibrated airspeed is going to reduce. All right. So how we looked at it initially is that we said that during the climb, if you maintain, so this would be pressure altitude and this would be speed. If you maintain a constant calibrated airspeed, in that case, because of the reduction in density, to maintain the constant dynamic pressure, your true airspeed would actually increase, right? However, what we can see in reality is that it's not really a constant that we have to maintain, because the maximum straight and level is going to decrease. In reality, the speed which we're able to maintain, the maximum straight and level speed, is actually going to be slightly decreasing. So it's not a straight one. It's going to be slightly decreasing as altitude increases, and there's a point after which it just declines very rapidly. I think it's visible, right? Because as you reduce altitude in both cases, it would just go lower and lower and lower, and essentially, it's going to come a time where this speed would start to reduce like very rapidly around the bottom of the drag curve, where this tangent is much flatter, right? So this is why you would have this effect in both cases, is that there's like an altitude where it starts to the pressure altitude where it starts to like very suddenly decrease with in a much steeper way. Okay, however, what we can see, if the calibrated airspeed is gonna decrease, it doesn't necessarily mean that, however, that the true airspeed is gonna decrease as well. So initially, when the decrease in the calibrated airspeed with the increase of altitude is small, in that case, the true airspeed is just gonna increase less. That makes sense? So for example, if you were maintaining a calibrated airspeed, let's say this would be your gradient. Like this was your true airspeed. But right now, because it's slightly decreasing, in reality, it's going to look like like this. And it's still going to increase, but much less steeply. Well, in the beginning it's going to be closer to this curve, and you know, at higher altitudes it starts to increase less and less, and there's going to be a point when it's going to flat out, and after that, because of this effect, this reducing effect, it's also going to start to eventually decrease as well. So this would be your true airspeed, and this would be your calibrated airspeed. So there's a point on the curve where you actually reach the maximum, the Vmax straight and level true airspeed. And interestingly, for both the jet and the propeller-driven aircraft, it's visible from these drawings that the maximum straight and level speed in calibrated airspeed is going to occur at sea level, right? So at the lower altitude is going to be the highest at sea level, basically, because after that is continuously decreasing. However, the true airspeed, so the max straight and level true airspeed, is going to occur at high altitudes. At high altitudes. And this is going to be very important later on. Okay. So basically, that is it for this video. This was quite a short one. And so what we learned from this one is that the maximum straight and level speed for both the jet and for both the propeller-driven aircraft occur where the thrust curve intersects the drag curve, so therefore where the thrust equals the drag. And this maximum speed with regards to calibrated airspeed is continuously decreasing as altitude increases for both cases. And we also see that, so therefore the calibrated airspeed is going to be highest at sea level and is going to continuously decrease as pressure altitude increases. But we can also see that the true airspeed is going to be highest at a higher pressure altitude. Right, and that was it for this short video. We're going to continue with talking about the range. Okay, so thank you for your attention and see you in the next video.